Graphs of parabolas. So just a few things that I want to go over before we jump into the questions. The standard form for the equation of a parabola with vertex hk is y equals a times the square of x minus h plus k. And that could be written in this alternative form, y minus k equals a times the square of x minus h. I like to think of it in this second form a little more because it's consistent with where the minus signs are. It also exactly mimics what the point slope form of a line looks like. However, if you see it in this form, it's not worth rewriting it in the second form. Just think about that if the k were over here, then they would both be minus signs matching up. Now, if a, this number right here, is positive, then the graph is an upward facing parabola. And if a is negative, the graph is a downward facing parabola. Okay, let's just make a little room. A few more things. So the general form for the equation of a parabola is y equals ax squared plus bx plus c. Now, this form isn't quite as nice as the standard form in the sense that you can't just see what the vertex is by looking at it. However, you can compute the x-intercept of the vertex very quickly with the little formula x equals negative b over 2a, which is definitely worth remembering. The discriminant of this form here is represented by this Greek letter delta, and it's equal to b squared minus 4ac. Knowing this little formula for the discriminant could save you some time in some problems. If the discriminant of this quadratic function is positive, then we know that the roots are going to be real and unequal, meaning that there are two different ones. If the discriminant is equal to 0, then the roots are real and equal, meaning there's really only one of them. And if the discriminant is negative, then the roots are complex. We can see how it looks in a picture here. This one here has a discriminant that's positive. You can see there are two roots or two x-intercepts. If the discriminant is 0, you see there's only one x-intercept. And if the discriminant is negative, you can see that there are no x-intercepts. It doesn't touch the x-axis at all. All right, let's jump into some questions. Let the function f be defined by f of x equals 3 times x minus 2 squared plus 1. For what value of x will the function f have its minimum value? All right, well, this is already in standard form, right? So we see that we could pick out the vertex just by looking at it. It's 2, 1, and we're looking for the x value of the vertex. That's where the minimum will be. So that is exactly 2, which is choice C. It's worth just kind of looking at a graph of this for just a second. We see that this is an upward facing parabola with a vertex of 2, 1. So it's going to look like this. I also just drew in the y-intercept there, which if you really wanted to find it, you could get it by plugging in a 0 for x. 2. If the equation y equals x minus 5 times x plus 7 is graphed in the xy plane, what is the x-coordinate of the parabola's vertex? I'm going to go through a few different ways to solve this problem, starting with the quickest, but I don't want to leave it at that because the other methods are useful, not just for this problem, but for solving more difficult problems as well. So first, the quickest solution. The x-intercepts here are -7 and 5, right? Because that's where plugging in a -7 here will make this 0, and plugging in a 5 here will make this 0. So the x-coordinate of the vertex is midway between those two numbers. So we just take the average. -7 plus 5 over 2 is -2 over 2, which is -1. And that's exactly what we're being asked for. So the answer is choice B. Let's look at another solution. Just copying the equation down, let's multiply this out by, say, foiling and get it into general form. Notice that x times x is x squared. Then we have the outers are 7x, the inners are negative 5x. 7x plus negative 5x is positive 2x. And negative 5 times 7 is negative 35. Great. So remember that little formula I gave in the beginning. The x-coordinate of the vertex is x equals negative b over 2a. So here we have a equals 1, right? There's a hidden 1 here. And b is 2. And c is negative 35. We won't need c for this problem, but I'll just write it down so you understand where all these things are. Now plugging in 2 for b, we get negative 2 over 2 times 1, because a is 1. And just simplifying that, that is negative 1. And that's exactly what we were being asked for, the x-coordinate of the vertex. So it's choice B, once again. Okay, another solution. This is going to be the longest solution, but the technique I'm going to go over here is very useful for many, many problems. So what I'm going to do is complete the square. So we do that by taking half of the coefficient of x, which in this case is 2, to get 1. I square this number 1. 1 squared is also 1. And then I go ahead and add 1 next to the 2x. And since I'm not really allowed to do that, I subtract 1 to the right of that. So I've really changed nothing, but I added this 1 to turn this expression into a perfect square. And these will just be able to combine together. Okay, so x squared plus 2x plus 1 factors as x plus 1 squared. This one could actually just be copied from the very first number that we got here. That's always the same number. And here I just combined the negative 1 and the negative 35 to get negative 36. Okay, so now we see that it's in standard form, a times x minus h squared plus k. And we can see that the vertex is hk, so minus h. So this is negative 1, and the k's match up. This is negative 36. But the important one is the x-coordinate of the vertex, which is negative 1. Once again, choice B. Which of the following best describes the nature of the roots of the equation x squared plus 8x plus 7 equals 0? Okay, so for this equation, we have a equal to 1, b equal to 8, and c equal to 7. And we're going to go ahead and compute the discriminant. Remember, we use this Greek letter delta to represent the discriminant, which is b squared minus 4ac. Here we have b equal 8, a is 1, c is 7. So let's just plug those in to get 8 squared minus 4 times 1 times 7. 8 squared is 64, and 4 times 7 is 28, and 64 minus 28 is 36. This is positive. 36 is a positive number. So using our little chart here, we see that the discriminant is positive, so the roots are going to be real and unequal. That narrows it down to choices A and B there. But also, the number 36 is a perfect square, which means that it's also going to be rational, choice A. Number 4, which of the following best describes the graph of the function y equals x squared plus 4x plus 8 equals 0? Okay, so once again, we have a equals 1, b equals 4, and c equals 8. We're going to take the discriminant. That's b squared minus 4ac. So b is 4, a is 1, c is 8. So we get 4 squared minus 4 times 1 times 8. That's 16 minus 32, which is negative 16. And the important thing about this is that it's negative. Okay, so since it's negative, we know that we get a parabola that does not intersect the x-axis. And the reason we know it's upward facing is because the coefficient of x squared is positive 1. The fact that it's 1 isn't important. What's important is it's positive. That makes it upward facing. Let the function f be defined by f of x equals negative 7x squared plus 3x plus 1. For what value of x will the function f have its maximum value? Okay, so we have a equal negative 7, b equals 3. And we're just going to compute x equals negative b over 2a, which is negative 3 over, well, 2 times negative 7 is negative 14. So that's 3 over 14. Or we could write that as the decimal 0.214. Consider the function f of x equals x squared minus 5x plus c. The graph of f in the xy coordinate plane is a parabola whose vertex lies on the x-axis. What is the value of c? Okay, so let's compute the discriminant, which is, once again, b squared minus 4ac. In this case, b is negative 5, and a is 1, and c is actually just written as c here. So we have the square of negative 5 minus 4 times 1 times c, which is positive 25 minus 4c. And since the vertex lies on the x-axis, the discriminant is going to have to be 0. So we just set what we just got for the discriminant equal to 0. So 25 minus 4c equals 0. So adding 4c to each side of that equation, we get 25 equals 4c, and divide by 4 to get c equals 25 over 4, or 6.25. Which of the following is an equivalent form of the function f whose graph is shown below in the xy plane, from which the coordinates of vertex p can be identified as constants in the equation? Okay, so I'm going to first show you a really quick solution. We could kind of cheat on this one a little bit, but just in case a problem comes up where you can't cheat like this, I want to show you the long way to do it too. So the quick way is just to notice that the standard form for the equation is going to be y equals a times x minus h squared plus k. The vertex of this equation is hk. And this is the form of the equation where you can identify the coordinates of the vertex as constants in the equation. The h and k are right there in the equation. So choice A is the only one that has that form. So it's the only one that could possibly be the answer. So that's a little sort of sneaky way to do it that doesn't require any work. But let's actually give a complete solution to this. Let's pretend we don't have the answer choices, just so we can see how to do it. So just starting with the given equation, right? The equation is given here. I'm just rewriting it. I'm going to factor out the minus sign from the first two terms in preparation for completing the square. So when you complete the square, the coefficient of x squared needs to be 1. So we can't do it from here because of that minus sign, so we pull it out. I like to just pull it out from the first two terms instead of all three, because we're going to have to get rid of this out of the parentheses again anyway, so there's no sense in putting it in. All right, so let's just give ourselves a little room here. And I'm going to complete the square again. Half of 4 is 2, and when you square 2, you get 4. So we need to add and subtract 4. Now notice something a little weird happened here. I added 4, and I could have subtracted 4 in the parentheses, but I needed to take that out of the parentheses anyway. So instead of subtracting 4 in the parentheses, I distributed the minus sign times that negative 4 to get positive 4 outside the parentheses. It'll save you a little time if you do this in just one step instead of two. Okay, now we have a perfect square here. Notice that this 2 is the same as here. And we just add up the 4 and the 21 to get 25. And we see here that this has a vertex of negative 2, 25. And look at that, this is choice A. The only difference in choice A is we wrote x plus 2 as x minus negative 2 because we want that negative 2 to appear as the question tells us. Okay, 8. Which of the following is an equivalent form of the function h below, in which the minimum value of h appears as a coefficient or constant? Okay, so we have h of x equals x minus 3 times x plus 7. All right, so I'm going to give a couple of solutions. There are several. I'm going to give two. So the first one is we could start with the x-intercepts like we did in an earlier problem, -7 and 3, because those are the two numbers that make this expression 0. The x-coordinate of the vertex is then midway between the two x-intercepts. So we just take the average. -7 plus 3 over 2 is -4 over 2, which is just -2. And the only one then that makes sense is choice D, because choice D has the x plus 2, or equivalently x minus -2, and this is written in standard form. Okay, another solution. So I'm going to FOIL this out. X times x is x squared. The outers is 7x, and -3x gives us positive 4x. And -3 times 7 is -21. Completing the square, we have 4 to get 2, and then square that number to get 4. So we're going to add and subtract 4. And now we get that this part here is a perfect square where we use this number, right? X plus 2 times x plus 2 gives us this. And we combine the -4 and the -21 to get -25. Well, look at that. It's answer choice D. Okay, 9. In the quadratic equation below, P is a non-zero constant. The graph of the equation in the xy plane is a parabola with vertex hk. What is the value of the square root of -k over p? And our quadratic equation is y equals p times x minus 3 times x plus 7. I'm just going to multiply out, once again, x minus 3 times x plus 7 to get x squared plus 7x minus 3x is plus 4x, and -3 times 7 is -21. Okay, this is all set to complete the square. I have 4 to get 2, and I square the 2 to get 4. So inside the parentheses, I add and subtract 4. Notice that -4 and -21, I'm going to combine to get -25. And then I'm going to distribute the p, but not to everything. I'm going to distribute the p to these and then to the -25 to get p times x squared plus 4x plus 4 minus 25p. And this first part in parentheses here is a perfect square, right? Which is given by this number. You could just pop that 2 in there. So we have p times x plus 2 squared minus 25p. This is in standard form. The vertex is -2 here, -25p here. Okay, so now we could compute the square root of -k over p is the square root of the negative of -25p over p. So all I did was replace k, right? K, that's k, by -25p. So we could cancel the p's, the two minus signs cancel, and we're just left with the square root of 25, which is 5. Okay, I saved the best for last here. The xy plane below shows the 2 points of intersection of the graphs of a linear function and a quadratic function. The leftmost point of intersection has coordinates AB, and the rightmost point of intersection has coordinates CD. If the vertex of the graph of the quadratic function is at 2, -27, what is the value of B minus D? Okay, that's a lot. Let's start with the standard form for the equation of a parabola, y equals a times x minus h squared plus k. So I'm just popping in the vertex, which is hk, in this case 2 comma -27. So I replaced h by 2 and k by -27. And now I'm plugging in one of the points that's given on the parabola, this point 5, 0. So since this is on the parabola, I can replace x by 5 and y by 0, and I get a true statement. So 5 minus 2 is 3, squared is 9. So that becomes 9a minus 27. And just solving this, I add 27 to each side. And then I divide by 9 to get that a is 27 over 9, or 3. So just substituting this 3 back into the equation that I have here, I get y equals 3 times x minus 2 squared minus 27. Okay, so we have an equation of this parabola in standard form. Next, we have to deal with the line. So we could find the slope of the line by using the two given points on the line that are completely known, 1, 3, and -1, 15. So I did 3 minus 15 over 1 minus -1. That gives me the slope. And let's just simplify that to -12 over, well, 1 minus 1 is 1 plus 1, which is 2. So that comes out to -6. So now I'm just using one of the points. I chose this point, 1, 3, together with the slope, and I wrote an equation of the line in point slope form. Y minus 3 equals -6 times x minus 1. Okay, and just solving this for y, I first multiply through over here to get -6x plus 6, and then add 3 to each side to get y equals -6x plus 9. Okay, so now we have an equation for the parabola and an equation for the line, and we need to find the points of intersection, right? So I'm going to, since they're both solved for y, I could set -6x plus 9 equal to 3 times x minus 2 squared minus 27. All right, we have to solve this for x now. So x minus 2 squared means x minus 2 times itself. So we FOIL that to get x squared. Minus 2x is minus 4x. And -2 squared becomes positive 4. All right, distributing the 3 through here, we get 3x squared minus 12x plus 12. Okay, and then so 3x squared, and we have -12x, and bringing this over, that becomes -12x plus 6x is -6x, and combining bringing the 9 over, subtracting 9, that's a 3 minus 27 gives us -24, and we wound up with a 0 on the left. I just switched the two sides so that the 0 is on the right instead of on the left there. Okay. Just dividing through by 3, right? 3x squared over 3 is x squared. -6x over 3 is -2x. And -24 over 3 is -8. And now we can factor this easily as x minus 4 times x plus 2. So we get two solutions, x equals 4 and x equals -2. Okay, so here's all the information we have. I have the equation of the parabola, the equation of the line, and I have the two x coordinates where these two curves intersect. So we still need to find the y coordinates where they intersect. So when x is 4, I could plug that into either of the two equations. It's easier to plug it into the linear equation. So we get y equals -6 times 4 plus 9, which is -24 plus 9, or -15. Okay, we'll put that there. And let's also do the same thing for x equals -2. I'm going to plug into the linear equation to get y equals -6 times -2 plus 9. That's 12 plus 9, which is 21. So that gives us the other y coordinate. Great. So AB has to be the point -2, 21. And CD is the other point of intersection here for -15. All right, and the question finally is asking for B minus D. Well, we have those numbers right here. B is 21, D is -15. So we get 21 minus -15, which is 21 plus 15, or 36.